The purpose of this chapter is to discuss how variables we measure can be reduced to numbers, or something that is measurable, in order to distinguish different levels of a variable that's observed. The characteristics that describe a variable are known as attributes. Attributes of a variable can range from only two, such as male or female, to several, such as different levels of income. Because variables have different attributes, they need to be measured in different ways. Depending on the nature of the attributes, variables can be measured in one of the four different ways: nominal, ordinal, interval, and ratio, which will be discussed later in the slide. So measurement is simply reducing something to numbers or categories. Variables are broken down into attributes, different types versus different numbers. Numbers are used in the positive approach, whereas words are generally used in the interpretive approach. The first level of measurement is the nominal level of measurement. In this level of measurement, the numbers and the variables are used only to classify data, such as words, letters, alphanumeric symbols are often used. Suppose there are data about people belonging to three different gender categories. In this case, the person belonging to the female gender could be classified as F, the person belonging to the male gender could be classified as M, and a transgendered person could be classified as T. This type of assigning classification is the nominal level of measurement. Simple categories and can be dichotomous, which means two or more. The second level of measurement is the ordinal level of measurement. This level of measurement depicts some ordered relationship among the variable's observations. Suppose we want participants to rank their client's satisfaction. To do this, we would use a Likert type 5-point scale to include all possible answers in order of rank. For example, the choices they can choose from are not at all satisfied, somewhat satisfied, moderately satisfied, generally satisfied, and very satisfied. The intervals between the first choice, not at all satisfied, and the last choice, very satisfied, have no mathematical significance. Rather, the selection the client made only indicates an order from which the selection was made. So they can be ranked, but cannot assume the same distance between the two measures. The third level of measurement is the interval level of measurement. The interval level of measurement not only classifies and orders the measurement, but it also specifies that the distance between each interval on the scale are equivalent along the scale, from a low interval to a high interval. For example, an interval level of measurement could be measured by the anxiety of a student. One student may have a score between 10 and 11, or one student may have a score between 40 and 41. The distance between the 10 and 11 and the 40 and the 1 would be the same. Another popular example of this level of measurement is in temperature. For example, the distance between 50 degrees and 100 degrees Fahrenheit is the same distance between 1,000 degrees Fahrenheit and 1,050 degrees Fahrenheit. For social work, intervals are most commonly used in connection with standardized measuring instruments such as IQ test or anxiety assessment. But it does not have a 0 point and can be reduced to ordinal if the ranges are used. The fourth level of measurement is the ratio level of measurement. In this level of measurement, the observations, in addition to having equal intervals, can have a 0 as well. The zeros in the scale makes this type of measurement unlike the other types of measurement, although the properties are similar to that of the interval level of measurement. In the ratio level of measurement, the division between the points on the scale have an equivalent distance between them. The variable income can be measured on the ratio level because it is possible to have zero income. However, on most measurement tools, 0 is not often included, and the income scale is often modified to an ordinal level by ranking the levels of income on a 5-point scale to account for the population being studied and to ensure responses are accurate. So ratio has a true 0 point, but can be reduced to ordinal if the ranges are used. The researchers should note that among these levels of measurement, the nominal level is simply used to classify data, whereas the levels of measurement described by interval and ratio are much more exact. This picture describes the different levels of measurement, starting with nominal, counts by category. It can be binary, such as 2 words, but can be more than that. No meaning between the categories, no value between the categories. And ordinal, you can rank things. It is a scale. The space between the ranks is subjective, which means it has no mathematical value. In interval, we use integers. The 0 is another value, but it's not the absence of something. Space between the values is equal and objective, but discrete. And then ratio, the interval data, is with a baseline of 0 means there is an absence of, and the space between each value is consistent. Describing variables. When we do any research study, positivistic or interpretive, we need to describe the variables we are studying as accurately and completely as possible for the four following reasons: correspondence, standardization, quantification, and duplication. Correspondence is making a link between what we measure and what we observed and the theories we have developed to explain what we have measured or observed. For example, using attachment theory to explain different behaviors of small children that are separated from their mothers. Standardization. Variables can be complex, and the more complex they are, the more likely it is that people will interpret the exact same variable in different ways. Using a standardized measurement tool will ensure that data can be replicated and viewed in the same way by all researchers. Quantification. Defining the level of variables in terms of single number of score, reducing a complex variable to a single number can create issues with capturing the variable accurately, such as self-esteem. But however, we can combine several variable scores into one overall score to accurately measure complex variables like self-esteem. Duplication. In our profession, we rarely replicate a research study, but we can duplicate them to confirm a researcher's results by doing the same thing later on. Criteria in selecting an instrument. In order to measure a variable, we need a measuring instrument to measure it with. In order to decide which instrument is best for measuring a particular variable in any given situation, there are 5 criteria that we must consider: utility, sensitivity to small changes, non-reactivity, reliability, and validity. Utility. Looking at the Hudson's Index of Self-Esteem Measurement tool, one would quickly realize that the participant filling out the questionnaire would need to be literate and have a higher comprehension level in order to place meaning to very abstract terms used in the tool. Sensitivity to small changes. An example in the text refers to a client that has a client with bedwetting incidents. As a result of the way the data was collected, the client's small improvements were not apparent in the data collection process because the information was collected as he or she wet or did not wet the bed for the week, rather than how many times per week. Non-reactivity. Ensuring the instrument does not change the behavior or feelings of a person that it was supposed to measure. For example, if you want to determine if an intervention is effective in raising the self-esteem of girls that have been sexually abused, then you need to make sure that any increases in self-esteem is due to the intervention, not the measuring tool. To ensure this, refrain from using the instrument tool as a clinical tool, such as using the scales or questions in the treatment. The Hawthorne effect refers to the alteration of a behavior by the subjects of the study due to their awareness of being observed. Reliability. Ensuring that the measuring instrument gives the same score over and over again, provided the measurement is made under the same conditions. A test-retest method is used to establish reliability. A researcher would administer the same measurement instrument to the same group of people on 2 separate occasions. The 2 sets of results are then compared to see how similar they are. If there are problems associated for clients using the same test, such as the testing effect that may alter the results, we must also take those in consideration. Alternate form. The alternate form method is a second method to establish reliability, giving a second form of the instrument that is similar to the first, but altered to reduce maybe some of the testing effects that may occur. Split half method. Splitting one half of the instrument in half so that it becomes 2 shorter instruments. This is done to ensure the original instrument is internally consistent, with no longer or more difficult items appearing at the beginning or the end. Observer reliability. People observing the same behavior with the same tool may come to different conclusions. It is therefore important for reliability that observers come together before the observations to discuss the tool, and then come to an agreement about observations after. Validity measurement. The following are the 4 kinds of validity measurements of an instrument: content validity, criterion validity, face validity. Content validity. Ensuring the information within the measurement tool contains content or indicators related to the variable in question. It is not possible to include every single aspect of the variable in question, however we must ensure that all aspects of the variable are included. criterion validity. If an instrument has criterion validity, that means it gives the same results as a second instrument that measures the same variable. There are two categories of criterion validity, concurrent and predictive. Concurrent validity refers to the ability of a measuring instrument to predict accurately an individual's current status. For example, a teacher and a test can both accurately identify a child who is at risk for reading at that moment. That would be referred to as concurrent. Predictive, an instrument's ability to predict future performance or status from a previous performance. Both concurrent and predictive are concerned with prediction. Concurrent predicts current status, whereas predictive predicts future status. Face validity, ensuring that at first look and by the appearance of the measurement tool, it actually looks like it's measuring what it intends to measure. This figure depicts the relationship between reliability and validity using an example of a person firing 5 rounds from a rifle at three different targets to adjusting the performance of the gun each time. Figure 7.2, the bullet holes are scattered all over, representing a measurement instrument that is neither valid nor reliable. Now let's look at figure 77.2b. You have adjusted your sights, and now all the bullets are in the same place but not near the center as you had intended. This represents a measurement instrument that is reliable, but because it's not near the center, it is not valid. Finally, all the adjustments are finally made with the sights, and in figure 7.2c, the shots hit near or at the bullseye. This instrument is now both valid and reliable. Measurement errors. No matter how reliable and valid a measuring instrument is, no measurement is without errors. The two most common are constant and random errors. Constant errors. Errors that stay constant throughout the research study. The source may be from the participant, the researcher, or even the tool. Participant as a source. If the person being interviewed has a tendency to agree with everything being asked of them to look good, this is called acquiescence bias. If the participant has a tendency to say anything that the participant thinks makes them look good, this is called social desirability. If the participant always chooses the middle of ground response because they have a hard time committing, this is called central tendency or fence sitting. The researcher. Interviewers can affect the answers they receive by the way they ask the questions, maybe by the way they dress, if they have an accent, their mannerisms, their gender, their age, their ethnic background, or even their hairstyles. The constant error is how we rate others as opposite to each other with a particular characteristic. Another error that can be caused by the researcher is the halo effect, or to think that a participant is wonderful or terrible because of one good or bad trait. The final example of how a researcher can produce measurement errors is the error for severity and the error of leniency. For error of severity, it's always giving a bad report no matter what. In the error of leniency, always giving a good report. Random errors are not constant and difficult to find, and there is little researchers can do about them. There are 3 types of random errors: transient, situational, and administrative. Transient errors are things such as fatigue or boredom that can affect the participants' responses. Situational factors, like the weather, or maybe a drill noise outside the room, or loud chatter outside that may affect the responses of the participant. And finally, administrative factors, anything related to the way the instrument is administered, such as maybe reading the instructions in a wrong way. So how do we improve validity and reliability? Be sure you're clear on what you're measuring. Better training for those who will apply the measuring instruments. Obtain the researcher participants' personal reactions about the measuring instrument before it's given to a large group of people. Obtain higher measurement levels of a variable, use more indicators of a variable, and conduct an item-by-item analysis to see if there are any questions that are causing issues with validity and reliability.